Hello all, welcome to this Autotronics course. So we are in the last week. So in this week we will continue the discussion related to this automotive diagnostics, which we had a discussion in the 11th week. So in fact we started with this spark plug. So before going into this, let me just introduce you to the different components which we will be discussing in this week. So one is with reference to the automotive system diagnostics, especially with sensor system and intermittent fault. And then we will also discuss about this topic on intelligent collaborative diagnostic system. And then we will also have a discussion on the IoT enabled condition monitoring and diagnostic system in detail. So before going into this, we will also have a discussion about the continuity of the previous week, where we had some discussion about the spark plug, especially the ignition system. What are the different diagnostics which we may need to follow with reference to ignition system? Already we have given an introduction to the spark plug. So if we look into the overall system diagnostics with reference to an ignition system perspective point of view, let me just represent this in the form of a simple flow chart. So first, as we had seen the diagnostic, the first level of diagnostics, it's a kind of a manual based diagnostics where we have high and I check, which also check the corrections and the cleanliness. The battery must be 70% charge. And we should check the supply to the ignition coil. Okay. Now, if the spark from the coil via is good, if it is S, then we have the if good spark, then check HT system for tracking and open circuit. If then we may need to set the basic dwell for cranking, and then we can connect it to the part. Similarly, if it is no, then we can consider it as if no spark, then we may need to go for the kind of a jump short start, and then we have to check the continuity of the coil winding. Supply the earth to the module. Then we have a supply to pulse generator if appropriate. Then we have the output of pulse generator. Then we have to replace the pulse. And then we have to look into the continuity of the low tension wires. And then finally replace the module if all the tests are satisfactory. Okay, and then you can end this module. Okay, so similarly in this particular case also, after you complete, you can end this module. Okay, so if you look into the overall configuration of these ignition system diagnostics, it starts with the manual like checking, and then the overall like battery backups are checked, and the overall ignition coils are checked. Main important aspect is the continuity, the earthing and the pulse, and appropriately we try to segregate the cranking as well as the open circuit in the system. Now if we look into the overall like symptoms as well as the possible fault with reference to ignition fault diagnostic table perspective point of view, the first symptom which we normally see is the kind of engine rotates but it doesn't start. Like for example, the engine will be rotating but it won't be able to start. This there are some chances like the possible fault may be due to the no fuel in the tank, or sometime air filter is dirty, or blocked fuel pump not running and no fuel being injected. Sometime what happens is it will be difficult to start when cold, so air filter dirty or blocked fuel system, wiring fault enrichment device not working, and the coolant temperature short circuit may also be one of the aspects. Sometimes it is difficult to start when hot, so air filter dirty or blocked fuel system, a wiring fault, coolant temperature sensor, it's a kind of an open circuit. Sometimes one of the key symptom includes the engine start but when stops immediately. So this may be due to the fuel system contamination, fuel pump, or circuit fault, relay or intake system, or there might be kind of a leak erratic idle. Now let us talk about the erratic idle. So the air filter blocked inlet system, the air leak incorrect, and the carbon monoxide setting idle air control valve not operating, and the fuel injectors which are not spraying correctly. Sometimes what happens is there is a kind of a misfire through all speed, the fuel filter blocked, fuel pump delivery, and low fuel ventilation system blocked. Next we have a kind of an engine stall. So it's a kind of an ideal speed, incorrect carbon monoxide setting, incorrect fuel filter, blocked air filter blocked, and intake air leak, ideal control system not working. So this may lead to the engine stall. When we try to talk about the lack of power, the fuel filter blocked, air filter, a low fuel pump delivery, or the fuel injectors are blocked. Sometimes we can also expect a backfires, which is a kind of a fuel system fault, airflow sensor in some cars and some ignition time. Now let us discuss about the components and the test methods. First is with reference to a kind of a spark plug. So compare nose condition to a manufacturer chart, inspect ignition secondary waveform, particularly when the engine is under load. As far as ignition coil is concerned, the resistance check of the primary and the secondary winding. The primary is 1.5 ohm ballasted to 3 ohm, secondary is 5 to 10 kilo ohm. Now we have a ignition switch where there is a voltage drop across the contacts. Next we have a ballast resistor. The resistance or check voltage at coil supply, which is approximately 6 to 7 volt when the contact breakers are closed. Then we have the contact breakers where the voltage drop across them and should not exceed approximately 0.2 volts. Then we have a capacitor where they charge the capacitor up to 12 volt battery. It connects a digital meter and watch the voltage discharge from 12 volt to almost 0 volt over approximately 5 seconds. Next, we have a centrifugal advance where it measures the timing at certain speed using an advanced timing light. Then we have a vacuum advance where it's a engine load is there. Apply a known vacuum and no timing change, or often just like a defect on the piping and noting movement is adequate. Let us see, this is a kind of a visual like representation where we can talk about the the overall about the new spark plug, the overall carbon fouled spark plug. This is a kind of a deposit spark plug, and this is the damaged insulation part, and this is the carbon fouled system, and this is a kind of an overheating system which is being observed in this arrangement. We will discuss about the diagnostic emission. So like as far as these diagnostic emission is concerned, so one option is if you have a EGR valve sticking, so the possible fault might be the built-up of carbon electrical fault. When we talk about the high CO and high HC, there is a rich mixture, blocked air filter, a damaged catalytic converter, and an engine management system fault. Now let us take a low CO and high C. So it has a misfire fouled plug, which is a kind of a weak mixture which exhibits. Now when we try to look into the low CO and low of normal HC, there is an exhaust leak fouled injector which exhibits, which might be because of the possible fault. Now if we look into the emission system chart, diagnostic chart, so we can represent this emission system diagnostic chart in the form of a flow chart. One is we have the start, a manual inspection, a manual check for clean and tight, run the vehicle up to temperature by road testing, by road testing, connect reverse counter and connect exhaust analyzer. Using throttle pedal, hold the engine speed up to throttle pedal, hold the engine up to 3000 RPM for 30 seconds. Then allow the engine to idle. Check idle, speed, and take gas reading when stable. So if you look into the overall configuration, so we can just make a decision tool where reading compare with manufacturer's recommended setting. recommended setting. And then, so here if you see, if it is no, then you can carry out the adjustment. The adjustment. If it is yes, then you have to remove all test equipments. Okay. So in this particular process, again, if you have, like, after carrying, once again you are checking for the manufacturer's recommendation. And a setting. If it is yes, you go for the remove of all equipment. If it is no, we can represent this as check the EGR system and check for the leak. Next, we can also check the engine management system, and then we are ending the process. So here also, after removing all the test equipments, we are ending the process. So if you closely look into the different characteristics of it, we have the run vehicle up to the temperature and connect the reverse counter and connect the exhaust analysis. Using a throttle pedal, hold the engine up to 3000 RPM for 30 seconds. Allow the engine to idle. So we are checking up the overall ideal condition, the overall exhaust analysis. We are setting up a benchmark. So within that benchmark, we see how much is the inclusion which is happening. Now, if we look into the various types of fuel injection components, so there is an airflow meter is there. This allows a direct measurement of air mass as temperature, and compensation is built in. So the air quantity helps to determine the fuel required. Then we have an electronic control unit, the circuitry to react to the sensor signal by controlling the actuators in the ECU. So the data is stored in the ROM. Next, we have a fuel pump where there is a pressurized fuel is supplied to the injector. Most pumps work on the centrifugal roller principle. The pump ensures a constant supply of fuel to the fuel rail. The volume in the rail acts as a swamp to prevent pressure fluctuation as the injector operates. So the pump must be able to maintain a pressure of approximately a kind of a 3 bar. Next, we have a fuel filter. The fuel supplied to the injector must be free from any contamination, or else the injector nozzle will be damaged or blocked. Next, we have the lambda sensor. The quantity of oxygen in the exhaust, when accurately measured, ensures that the fuel air mixture is kept within the lambda window, which is in the range of 0.97 to 1.03. Next, we have the temperature sensor, where we have the simple thermistor which is used to determine the engine coolant temperature. So we have a fuel injector in place. So these are simple solenoid operated valves designed to operate very quickly and produce a finely atomized spray pattern. Next, we have an idle or fast idle control actuator. The rotary actuator is used to provide extra air for cold fast idle condition and to control the idle speed. It is supplied within the variable duty cycle, which is in the form of a square wave, and it also has a fuel pressure regulator. This device is to ensure a constant speed differential pressure across the injector, and it is a mechanical device and has a connection to the inlet manifold. Now, this is the overall fuel injection system outlay. So, in this fuel injection outlay, so we have an electrical pump connected with the fuel filter. Then there is an hot wire mass airflow meter is there, a pressure regulator is there, injector is there, followed by a temperature sensor and a sensor. We have an electronic control unit and a throttle portion switch in place. Let me just represent this in the form of a simplified block diagram, where you have an ECU, which is nothing but the electronic control unit. We have the engine speed, engine load, the coolant temperature, throttle position, the exhaust gas O2 content, and the battery voltage. So, the engine speed is there, engine load is there, coolant temperature is there, a throttle portion, exhaust gas O2 and the battery voltage, which is fitted to a fuel injector and then with a ideal speed control. So, this is the overall configuration of a fuel injection system. Now, let us discuss the injection fault diagnostics table. So, in this injection, the first symptom is the engine rotate, but if it doesn't start. So, there it is supposed that there is no fuel in the tank and the cam belt broken and the fuel pump drive a broken open circuit supply to stop the solenoid fuel filter blocked. Next, if there is an excessive smoke is coming, then it refers to the kind of the timing in incorrect gear, or it is set too low injector nozzles, or warm out kind of operation which exhibits over here. Then it may also result in the a kind of a wear out of the Then if with reference to difficult to start, it's a kind of a timing incorrect and a glow plug not working. As far as lack of power is concerned, it's a kind of a timing incorrect, governor set too low injector nozzle and warm injector operating a pressure incorrect. Sometimes what happens is the fuel smells in the car, the fuel line leakage or leak of pipe is broken. Then we have a diesel NOC where there is a timing incorrect, glow plug hold on for an ideal circuit which is not working. So there is a kind of an engine oil contaminated with the fuel which is due to the piston broke and a working piston ring excessive fuel. So now let us discuss about the glow plug circuit. So as far as these glow plug circuits are concerned, it's a typical glow plug circuit controlled by an ECU. A timer circuit puts the glow plug on for a few seconds before cranking. So a warm light may be used to indicate a ready condition to the driver, which take care to note the type of the glow plug which used. Most are 12 volt connected in parallel, but some are connected in series, which is in the range of 4 to 3 volt plug. So to check the operation of most of these 12 volt glow plug circuits, which uses the following steps. One is a kind of hand and eye check, and then we have a battery condition at least 70%. And engine must be cold, and it might be possible to simulate this by disconnecting the temperature sensor. Now with reference to the voltage supplied to a plug, when the ignition is switched on, a spring loaded portion, in some cases it is in the range of 10 to 12 volt. A warming light operation should go out after a few seconds. The voltage supplied to the plug while cranking will be in the range of 9 to 11 volts, and the voltage supplied to plug after the engine has started will be in the range of 0 volt, or if the silent idle speed is in the range of 5 to 6 volt for several minutes. So the same tests with engine at a running temperature and globe plug may not be energized or only by the starting phase, which is being exhibited over here. Now if you closely observe the overall circuit of a globe plug, so in this case we have an ignition switch in place, and then there is an ECU is there, and then we have a coolant temperature sensor with a low wall sensing resistor, and a 12 volt globe plugs are available within the system. Now let us discuss about the engine management fault finding chart in detail.